Welcome to Tenor Tech, where I solve the problems you didn't even know you had.
You begin by turning a plan into action, secure a stator core, and prepare copper winding. Start winding immediately. Aim for tight, even turns to minimize resistance and stray inductance. Use 2822 AWG depending on current, thicker wire for more torque, thinner for higher RPMs. Once done with a coil, varnish lightly so windings stay put at speed. Make sure to mount precision bearings now so shaft alignment stays true. Misalignment kills RPM and increases vibration. Next, assemble the rotor and focus on dynamic balance. Glue magnets in alternating polarity, keeping gaps equal. Unequal spacing causes cogging and limits speed. Once magnets cure, mount the rotor and check runout, trim material or add counterweights to hit near 1 gram balance tolerance. Replace bearings with minimal friction types and use a short, stiff shaft to prevent bending at high RPM. Then test spin slowly, monitoring vibration. Incremental increases reveal flaws before catastrophic failure. Finish by wiring the motor to a controllable driver and set a soft start profile so you can ramp RPM gradually. You want to monitor temperature, vibration, and electrical current. These tell you if windings overheat or bearings bind. Once at target RPM, validate stable commutation and no abnormal sound. If problems appear, slow down immediately. Check alignment, magnet seating, coil resistance, and driver tuning. Adjust spacing or rebalance rotor, and repeat tests. This iterative tuning is how you...
Thanks for watching. Subscribe to keep your life in tune.